What's up, everybody? Got another video here for you. This is an integral, integrals for multivariable, and you may be familiar with integrals, single variable, with U substitution. Well, this is like U substitution, but multivariable. All right. So let's see what we've got. We've got the double integral over the region R of x squared dA, where R is the region bounded by the ellipse 9x squared plus 4y squared equals 36. X is equal to 2u and y is equal to 3v. That's going to be our substitutions there. All right, so let's go ahead and get started. So notice we have x is equal to 2u, y is equal to 3v. So what we're going to do is we're going to take that and we're going to plug it into here. But before we do that, we're going to divide each of these by 36. And this is an ellipse. Remember, you want it to equal 1. So this is going to be x squared over 4 plus y squared over 9 equals 1. And if we make our substitution, we're going to get 2u squared over 4 plus 3v squared over 9 equals 1. And so basically what that's going to give us is that's going to give us u squared plus v squared equals 1. Because remember, 2u squared is 4u squared, the 4's cancel, and 3v squared is 9v squared, the 9's will cancel. All right, so this is our region S, okay? So we have our region R, which is an ellipse, like this. This would be -2, 2, 3, -3. And what we've done is we made a change of variables. This is x, y, and this would be u, v down here. And this is just a circle with radius 1 centered at the origin. This u squared plus v squared equals 1. All right, so we have our region S is the region of u, v, such that u squared plus v squared equals 1. This is our region for our change of variable. Now, if you remember to do the, when you do the change of variables, you've got to multiply by the Jacobian. So, do you remember what the Jacobian is? Well, remember, we got the partial of xy partial uv is equal to, and that is going to be let's see, what is that? That's the partial of x with respect to u, partial y with respect to u, partial x with respect to v, partial y with respect to v. And that is going to be, well, let's look at this. We've got our x and y here. We can see that the partial of x with respect to u is equal to 2. The partial of y with respect to u is equal to 0 because it's just 3v. That's a constant. And then we've got the partial of x with respect to v. Well, there's just a u there, so the partial of 2u with respect to v would be 0 because that's considered a constant. And then the partial of y with respect to v, that would be 3. So this would be 2, 0, 0, 3. And that would be 2 times 3, which is 6, minus 0 times 0, which is 0, which equals 6. So that's our Jacobian. All right, so now, if you recall, we're integrating. This is a circular region now. So do you remember going to polar coordinates? So we've got the u-axis here, the v-axis here. So we've got u is equal to r cosine theta, v is equal to r sine theta. And so now let's make our substitutions. So remember, our original problem was the integral over the region R of x squared dA. X squared dA. All right. So now this is going to equal our integral over the region S. We're doing a change of variable here. So that's going to be 2u squared. Because see, remember, x is 2u. Okay, so we're replacing this x here with 2u. And then that's going to be times what? Times 6 times the Jacobian. Let me go ahead and do this real quick. Let me write this down for you. We'll write it in a different color here. Remember, the integral over the region R of f of x, y, dA is equal to the region, the integral, double integral over S of f of x of uv, y of uv, times the Jacobian du dv. That's what we're doing right now. So you can see what we did here is we replaced the x with what it equals, which was 2u, times the Jacobian, which is 6, and then we've got du dv. All right, so this is the double integral of, let's see, that's going to be 4 times 6, that's 24. So that's going to be, let's do this. Let's write this as 24 times the double integral u squared. Let's not do u squared just yet. I'll tell you what, let's do this. Let's just do this. 24 double integral over s u squared du dv. We'll simplify it. All right. So now we're going to get 24 times the double integral. Now, notice here we've got our radius is going from 0 to 1. So we're going from 0 to 1, and then we're going all the way around. And so that's from 0 to 2 pi. And that is going to be u squared. Well, what's u? U is r cosine theta, so that's r squared cosine squared theta. If we square this, we get r squared cosine squared. And then remember, it's times what? Times r dr d theta. All right. And so now we get, let's see, 24, 0 to 2 pi, 0 to 1, r cubed cosine squared theta dr d theta. So all I did was multiply r times r squared there. And so that's going to be 24 from 0 to 2 pi of, what is that, 1/4 r to the 4th cosine squared theta. And r is going from 0 to 1 d theta. We're integrating this with respect to r. The cosine squared theta is considered a constant. Okay. And so this is equal to 6 times the double integral 2 pi. Not the double integral, but the 6 times the integral 0 to 2 pi. So I took the 1/4 and brought it out. And that's where the 6 comes from. And then we've got 1 to the 4th minus 0 to the 4th. And then that's times cosine squared theta d theta. All right. So we're plugging the 1 in for r and the 0 in for r. That's where this comes from. And then it's cosine squared theta. That's a constant. And so this is going to give me 6 times the integral 0 to 2 pi of cosine squared theta d theta. All right. Now, so now we have to integrate this thing. All right. All right, so let's see what we get. We're going to get 6 times the integral 0 to 2 pi. Now remember, cosine squared, we got to use our half angle identity plus 1 cosine 2 theta d theta. So that's just my half angle identity. And so that's going to be 3 times 0 to 2 pi 1 plus cosine 2 theta d theta. I just brought the 1/2 out. That's all I did there. All right, so now we get 3 times, and that's going to be what am I doing? That's going to be theta plus, now what's the integral of this? All right, so the integral of that is going to be plus 1/2 sine 2 theta, and theta is going from 0 to 2 pi. All right. All right, so let's see what we get here. So this is going to be 3 times 2 pi plus 1/2 times sine of, now when we plug the 2 pi in there, that's going to be 4 pi minus, that's going to be 0 plus 1/2, 0 plus 1/2 sine, and then we plug the 0 in, sine of 0. And so, I mean, this is 0, this is 0. All of this right here goes to 0. And so we got 3 times 2 pi is 6 pi. And that is your answer. All right. So I hope you enjoyed that video. I hope it helped. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.